There are two different topics in this unit that we've talked about. Okay, so the first one was called arithmetic sequences. Arithmetic sequences, okay? And we talked about the fact that there was the explicit formula and the recursive formula. Okay, so here are those two. We've got a sub n equals a sub 1 plus d times n minus 1. And then the recursive was a sub 1 equals a sub n equals a sub n minus 1 plus d. So take a second, write those down. Yes, I will give you those on the test, so no, you don't have to have them memorized. Okay, with explicit, remember a sub 1 is our first term. D is what we're going up by or down by. N is the number of terms. And a sub n represents the term we're looking for. Same concept as over here. A sub 1 is the first term. D is the common difference. This a sub n minus 1 is the previous term. And a sub n is the number we're looking for, the term we're looking for. Let's say I give you this example. I say a sub n equals negative 5n plus 8. Nope, JK. Let's do negative 6n plus 2. See that? Okay. And I say write the recursive and write the first 4 terms. Okay. So I believe that it's probably easier to start off with the first 4 terms. So if we were doing this, our first 4 terms would be found by plugging in 1, 2, 3, 4. So we're going to plug 1 into this equation. So instead of that n, we're going to write a 1. So negative 6 times 1 is negative 6, plus 2 is negative 4. If we plug 2 in, what do we get? Okay. If we plug 3 in, what do we get? Negative 16. And if we plug 4 in, what do we get? Okay, good. So those are the first 4 terms. Okay. Now, how do we write the recursive formula? Well, we take our equation and we say a sub 1 equals, well, what was our first term? Negative 4. So we're going to write negative 4 in there. What are we going down by each time? Okay. On y'all's mastery checks, a lot of y'all just put 6. Are we going up by 6 or down by 6? Down, so we need to put negative 6. A lot of y'all just put 6, and that's not correct. Okay, so you need to make sure that you put negative 6. And this right here is the recursive formula. If we're given a sub 1 equals 8, and a sub n equals a sub n minus 1 plus 3, can you write the explicit formula for this one? Remember, here's our explicit formula. So what was our first term? 8. So we're going to say a sub n equals 8 plus what was our common difference? 3. And then we're going to say n minus 1. Now, you're going to want to simplify this. You want to expand it as much as you possibly can, okay? So we're going to write that out, and we're going to say 8 plus 3n minus 3. And we see that 8 minus 3 is 5. So we'll get a sub n equals 5 plus 3n. Any questions over that one? So they gave us the recursive formula, and we went to the explicit. So find the first 4 terms of this sequence. 4 terms. We know that the first term is what? 8. Can you find the next one? Okay, so what'd you get? Let's go back to the recursive. What are we adding by each time? 3. So what's 8 plus 3? Okay. And then what's 11 plus 3? And then what's 14 plus 3? Boom, done. That's why recursive is kind of cool, because it's what you do naturally in your mind. If I tell you, hey, add 3 each time, you could do that, okay? Now with explicit, what you can do is you can plug in 1 and you'll get 8, 2 and you'll get 11, 3 and you'll get 14, 4, you'll get 17. The recursive and the explicit describe the same patterns. There will be a question that they ask, does it describe the same pattern? You're going to say yes. And the reason why is because you plug in 1, you're going to get that first term. Then you can find the next term. Then you can find the next term. Okay? The answer is yes. Recursive and explicit find the same thing. They just go about it in a different way. Cool? Okay? Last little thing on this one. If I give you this table and I say the third term is 14, the fifth term is 20, and I say write the explicit. How would we go about doing that? What do we first need to do? Probably like fill in that table, right? Okay, so how do we figure out? Well, what's halfway between 14 and 20? 17. Okay, so what's the difference between these? Okay, so now can you go backwards? Okay, and then what? Do you see it? So if you have like a space in between 2 numbers, find halfway between those, find the common difference, and then start counting backwards. Okay, this one's a little tricky. This one's probably going to be the one that gives you trouble. Now, how do you write the explicit from that? Say 8. Okay. Right. And then we can distribute, and then we can simplify, right? Which we already did on the last one. Any questions about arithmetic sequences? Systems of inequalities. So systems of inequalities. Okay, so kind of make like a section on your paper for that one. Okay, I'm gonna level with you. I do not want you graphing these by hand if you can avoid it. I want you to plug it into Desmos and then copy down what Desmos has. Okay, because otherwise we make a lot of mistakes that way. Okay, so we got systems of inequalities. If I give you a graph and then I give you choices, could you graph it and recognize the graph from there? Like if I said, no, I don't have a way to do this without telling you the answer. Okay, so if I give you something like this, what would you do with that? I would go to Desmos, right? And then if I asked you to graph it, I would go into Desmos. I would type it exactly how I see it. I wouldn't rearrange it at all. Okay. And then I would zoom out just a little bit. I would pick some couple of points so that I could graph it. Try to graph some whole numbers, not like decimals. That would be great. Okay. Make sure that you have it dashed or solid. And fortunately, Desmos does that for you. You don't have to remember it. You don't have to remember if it's shaded above or below. Okay. Now, what would be a solution to this graph? What would be a solution to this graph? Okay, solution would be, you're saying 0? 0, 0? Yeah. What else would be a solution to this graph? Say it again. 0, -3? Okay, cool. Anything on this line would also be a solution. But nothing on this line would be a solution. Why? Because it's a dashed line, right? Dashed line, not a solution. Solid, yes. Okay. If you don't know how to like read coordinates on a graph, here's how you check it. Let's say it's a multiple choice question and they say, hey, -2, 3. Is that a solution? Okay, I'm gonna clear this off real quick. The answer is no. Why? Because it's not in the overlapped colors. Cool. Okay. If something says prove algebraically. Ooh, JK. Bless. Prove algebraically. Can't spell today. That this point is not a solution. What we would do is we would plug it in for these two inequalities. So you see this point, X and Y, we're going to plug it in here. So I'm going to take that first inequality and I'm going to substitute this in. So that would give me -2 plus 3. What's -2 plus 3? 1. Is 1 bigger than -5? Is 1 bigger than -5? Yes. Okay, so that's correct. However, I've got to check the second one. So when I plug it into here, I'm going to get 2 times -2 plus 4 times 3. Is that less than or equal to 3? Well, when we simplify this, this gives me 8 is less than or equal to 3. Is this a true statement? Is 8 less than 3? No. So this is wrong. This is not a solution. Again, this is going to be the one that probably trips people up. Are we okay on that? Do you want to try one? Yeah. Okay, take the points 3, 4 and prove algebraically if it's a solution or not a solution. So I got 9 is bigger than -5, which is right. 22 is less than or equal to 3, which is wrong. Oh, nope, JK, 7. I don't know where that came from. You are correct. Okay. It was totally a 7. Yeah. Okay. Questions on that? We can also check and see this visually. Where is 3, 4? It's right 1, 2, 3, 1, 2, 3, 4. Right here. Is that in the overlapping shaded region? No. Obviously, you can see that's not a solution. Good? Okay. The last problem on your test is a word problem. Okay. It's very much like the thing that's on your review guide. So if you want to flip to, I think it's number 7. Yeah, number 7. So either number 7 or number 12, it's going to look like that. Okay. So when you create that scenario, you really want to pay attention to the like words like at least or normal, no more than, or stuff like that. Okay. Are there any questions on 7 or 12? Are we okay on those? I know those are a little tricky. This is the distinguished question. So can I do 7? Yeah, let me do that. Okay, yeah. All right, so looking at 7. Okay, I'm not going to pull it up, but you have it on your paper. Okay, so on number 7, it says, the state fair is coming to town. Natalie has saved up $12 to spend at the fair on games and rides. The games cost $2 and the rides cost $3. Okay, so games are going to be X, rides are going to be Y. Because those are the two things that we're talking about, right? So how much are games? Games are 2X. How much are rides? 3Y. And how much money do we have in total? 12. Can we spend more than or less than $12? Less than. But we can spend up to $12. Okay, now what you're going to want to do for your problem, it's going to be a system. So there's going to be 2 inequalities. Okay, you're going to want to graph them using Desmos. Okay, so if we graph this, we would get something like this. Okay, now, can we have negative values in the real world? No. So what you're going to see is kind of like a graph like that. It zoomed in to the positive side. Does that make sense? Okay. Now, you're going to try to tell me solutions that would work. So what solutions would work from this? 2, 2. Anything else? 0. Well, 0, 0, we don't really want to have, right? She could save up the money, I guess. What about 2, 0 or 0, 2? Okay. Now, can you explain the reasoning behind that? Because what? Because it's inside that shaded region, or you could say that it fits for the inequality or something like that. Okay. Now, again, on your test, it's going to be 2 inequalities. So you're going to write 2 different inequalities. Okay. This one didn't have 2 parts to it. Okay. Questions? Yes, ma'am. Beautiful. Glad you asked. Okay. So this is recording. Yeah. Okay. On your Desmos, down here, there's a little keyboard. And here are all of your inequalities. Okay. Now you can type it using your keyboard. You hit Shift and then either the comma or the period. If you wanted equals underneath, then you just hit equals immediately after. Okay. But you don't have to memorize it. You can just use the keyboard. Sometimes on like the little test program, you have to like zoom, like you have to kind of zoom out just a little bit so that you can see the keyboard. So if you have trouble seeing it, just let me know and I'll come by and I'll help. Okay. Anything else? Okay. How do y'all feel about this? Meh? Mid?